Assalamualaikum, my name is Masrura binti Abdullah, which is number CE190021. So I'll present for our introduction. So our scenario for our introduction is analyzing and changing a signal to improve or maximize its effectiveness of a performance as known as a digital signal processing, which is a DSP. So to create a signal of the higher quality than the original signal, several mathematical and computational approaches are applied to analog and digital signals in digital signal processing applications. Infinity impulse response is a form of digital filter. The function of filter is allow certain type of signal to pass while blocking others. The infinite impulse response filter is distinct in that it employs a feedback mechanism. So an FIR, finite impulse response filter, is one whose impulse response recurs to zero after a finite amount of time. If the impulse response exists endlessly, the filter is an IIR, is infinite impulse response. The method by which the output values are calculated determines whether a digital filter impulse response falls to zero after a certain period of time. Lastly, the system are described by a signal known as an impulse response using the impulse decomposition method because convolution connects the three signals of interest, which is an input signal, the output signal, and an impulse response as crucial.
Assalamualaikum, my name is Shahida binti Kamal. My matrix number CE19010. So I will explain partly literature review. Digital filters are systems that filter signals that contain both useful and undesired information. Filters are used to remove undesirable frequencies from applied signals. Digital filters are classified as either finite impulse response, which is FIR, or infinite impulse response, IIR. The infinite epistemic digital filters have fewer design parameters, memory needs, and computer complexity than finite impulse response digital filters. They are feedback type recursive system. Next, due to their ease of use and versatility, FIR digital filters have become quite popular in recent years. However, the design of the filter to eliminate noise and achieve a precise frequency response with high stop band attenuation and low stop band and pass band ripples also becomes crucial at the same time. One of the most popular computing tools in systems for digital signals processing is the IIR filter. In addition to being often utilized as custom design digital blocks, digital IIR filters are used in a variety of applications, including high-speed and low-power communication transceivers. The impulse response of IIR filters has an indefinite period, making them infinite response filters. Feedback from the output side to the input side is found in IIR filters, which are recursive filters. The response of an IIR filter depends on the most recent input samples as well as the input samples from the past and present. Digital IIR filters are one of the most widely used computational tools in digital signal processing. High-speed and low-power communication transceiver systems are only a few examples of the many applications it is employed in. So that's all. Thank you.
So for our problem segments, the majority of the distortion and interference make it difficult for signal to recover, so the communication system transmission quality will be significantly impacted by this issue. So to combat the interference and noise in audio signal processing, digital signal filters such as FIR and IIR filter are introduced. The primary advance of applying a filter design based on finite impulse response is the ability to produce linear phase frequency response, which is FIR. So an infinite impulse response IR filter must be created by optimizing a set of the filter coefficients. The filter coefficients must satisfy a number of required, including the pass band, width, and gain. So lastly, the study on infinity impulse response is a LRR. Filter must be created by optimizing a set of the filter coefficients. That's all from me. Thank you.
Assalamualaikum, my name is Muhammad Akimi bin Mustafa Kamal. My metric number is DE190067. So I'm gonna present about the objective. Uh, so the objective for our group is to design suitable finite impulse response (FIR) and infinite impulse response (IIR) filters using MATLAB software for denoising the provided audio input. The second one to examine and model how IIR and FIR bandpass filters are used in digital signal systems, as well as how they filter the input signal. And the last one to learn about and comprehend the discrete Fourier transform method used to express the frequency response of an audio signal, as well as the analysis Z transform method used to represent digital filters.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azam bin Nun Harun, DE190031, and today I want to present about methodology. Okay, first is signal filter. In order to identify the answer for this project, we must first determine the system output signal using the convolution method. Before we can see the signal, it must first be represented in frequency domain using discrete Fourier transform method. The discrete time signal, which consists of a series of real or complex value, is then converted using the Z transform into a complex frequency domain, sometimes referred to as Z domain or Z plan representation. Okay, for MATLAB is used to build and simulation discrete time filter, including finite impulse response, which is FIR filter, and infinite impulse response IIR filter IIR. Okay, FIR filter offer impulse response for an infinite amount of time, whereas IIR filter provide impulse response for an infinite amount of time. We can observe in the development of this project that the design specification and the parameter of the filter are continually altered in order to get the desired result when the digital filter is applied to an audio stream. In addition, the reduction and filtration of the original signal input component in one or more frequency band using a finite impulse response or FIR is created using a Hamming window function, while the Butterworth filter is signal processing filter designed to provide a smooth frequency response, no ripple, as flexible in the pass band, and zero roll of response in the stop band. IIR filter utilize Butterworth filter. Okay, this is the flowchart, which is it start, and after that it will write command ts value, and it went to put the given value of amplitude V. So we choose another one, which is we want to use IIR filter or FIR filter. So if we use IIR filter, we can see the formula there, and they will check for error. Also for the FIR filter, it will go to the formula and it will check for the error. If yes, it will plot the graph, or if no, it will go from the before the formula. Okay, after that it will plot the graph. If we check it doesn't have error, and it will be end after all complete. Okay, for the formula, this is the formula. For the first one is infinite impulse response filter IIR, and the second one is finite impulse response filter FIR formula. Okay, that's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azam bin Waharun, DE190031, and today I want to present our project, which is FIR filter. So first we had used the Excel that given and convert into MAT MAT format, and after that we use it in this code as for the input signal. Okay, next for DFT technique, which is discrete Fourier transfer, we use subplot for the signal group 7 for to show the signal, and magnitude spectrum, and the third one is phase spectrum. Okay, next here is the spec of the value that we declare. For BLO, which is here, we use the low pass filter, and for 50 is the value of n, and 51 is the value of 50, which is 51 is n plus 1, and for Nyquist rate here we use 0.3, and for to run this equation, to run this program, we use Chebyshev window here, Chebyshev window. Then okay, for the coding that I highlight here will show you the output after being filtered. Okay, next I will show you when I run this section by section. So this section I will run here. Okay, for the figure 1 here, it will show the input frequency signal, input signal here. Okay, next here I will run for this section. Okay, for this section, from the previous I had told that here will be a signal for subplot 1, signal for subplot 2, which is magnitude spectrum, and for subplot 3, which is phase spectrum. Okay, next I will run for this section.
Sampai
Okay, as you hear the output, from the output that you hear from the song that come, there was clearly, and because it was being filtered, and it doesn't has noise and distortion. I think that's all from me. Thank you.
Okay, Assalamualaikum. I will continue for IIR for Group 7 project. First, here is the coding for uh, input, which is first input is here is signal input, and here is magnitude spectral input, and here is phase spectral input before it filter, and after here is IIR filter. So the value here we take from the from after we run this section, this first section, to get the value at the magnitude spectrum here. And for elliptical, we use N is 9, RP is 6, RS is 90, and for WN is 2 pi FC. The output we get, we want to get, which is the signal after we filter, and the magnitude of spectrum after filter, and the phase spectrum after filter. So we run. Okay, here as you see is the amplitude and magnitude of spectrum. Here is the signal input, magnitude of spectrum, and here is the phase spectrum before we filter. So for the value here 17699.6. okay, for FC, the value here. Okay, to get the output for this IIR filter for this section, for the output signal. Okay, to get the output for IIR filter, I will run this section. Okay, for this is the magnitude response output, and here is the signal after we've been filtered, and here is the magnetic spectrum after we filter, and then here is the phase spectrum after we filter. Okay, as you hear, there was the song was clearly, but little bit slowly. I think that's all from me. Thank you.
And about the conclusion, in order to attain the closest ideal filter responses, we compared and examined the simulation result between FIR and IIR filters using the MATLAB simulator by comparing the differences in the amplitude and convolution and phase spectrum. This study indirectly taught us about the full range of technique used in digital signal processing. A mathematical technique called convolution combines two impulses to create a third signal. Digital signal processing also heavily relies on the FIR and IIR filters. The filters are simple to use and can be utilized in a variety of ways depending on the output required. So that's all from me. Thank you.